Let's take a real life example. Suppose you are a customer and looking out to buy a new washing machine. You go to the store, the salesman shows you a feature rich machine, but you realize that the machine is complicated to operate and you have to read the user manual to thoroughly operate it. The salesman shows you another machine which is not feature rich but does the job perfectly. What's more, you need not read the user manual to operate it. So which one would you buy? Based on the ease of use, a general opinion would be the second machine. Now APIs are no different. Think of an API as a product which unlocks the organization's data assets, and you as the developer or consumer of the API. Would you like to use an API in your application where to do any trivial operation you have to read the documentation? Or would you use an API that is intuitive and needs quite less visits to the documentation? The answer would be the second option, cause no one likes to spend the time in reading documentations. When an organization exposes its data assets using APIs, there could be two possible consumers, external and internal. In case of external consumers, the organization will be looking to monetize the APIs, and if the API is complicated, the consumers will search for better alternatives and not use your API, thereby hitting the revenues of your organization. If it is internal, the development teams might struggle with understanding the operations and thereby impact the deliverables. Both the cases point to a lose-lose situation. So it is very important that the API should be well structured, consistent and intuitive so that the consumers of your API are happy. Now that we have understood the need for a well-designed API, let's get started. Let's understand the basics. Let's start with resources. So a resource is an object or representation of something which has some associated data with it, and there can be a set of actions to operate on it. For example, employee, order, and customer could be resources, and there could be multiple employee, order, and customers, and this together form a collection. So a collection is of a resource, like employees collection has employee resource. Now when I talk about a set of actions to be performed on a particular resource, for example employee, order, and customer, it means that I can do operations like create, read, update, and delete, which is nothing but post, get, put, patch, and delete. Now let's move on to naming the resources. While naming the resources, you should always use nouns. For example, employees, orders, customers. You should avoid the usage of verbs in resources like get employees, delete employees, update employees. Let's understand these two things with the help of the screenshots. So in the first screenshot, we have a resource named as get employee and the HTTP action or verb as get. Next we have a post action and a create employee resource, and the same is the case with the third put action with update employee. So there are two problems over here. First, it is redundant because the resource says get employee, but it already has an action called get, and for any HTTP request the action is compulsory. So having a get employee again makes it redundant. Next, for a single object, that is employee, you can also call it as resource, you ended up creating multiple resources, like for employee, get employee, create employee, update employee, and there could be many more depending upon the number of actions you want to do on it. So these two problems can be solved by using nouns. Let's see the second screenshot. There is employees resource. In all the actions we can see only employees resource, but what we want to do is conveyed by the action, that is get, post, put. So the verb part is already taken care by the action part of the HTTP or HTTPS protocol, and that's the reason adding verbs to the resource makes no sense, and also it creates multiple resources. So you should avoid using verbs in resources and always use noun. The third point is you should use plural and not singular nouns. For example, multiple employees will be there in an organization, so that would be a collection of employees. So when you want to fetch a single employee, you can use a URI parameter as shown in the example, like employees 1 2 3 4. So always use plural noun, which says that okay, this is a collection of resources, and if you want to get a single resource, you can add a URI parameter, and that again acts as a resource. Avoid using abstract nouns when naming the resources. It is also known as concrete nouns in some cases. So you should avoid making the resource name too abstract, because tunneling a number of objects through an abstract resource makes it difficult to understand what the resource actually represents or how it should be used. For example, you have an employee's resource and we are searching for 1 2 3 4 employee, that is employee with ID 1 2 3 4, and then there is an abstract noun called services. Now if I am the developer or the consumer of this API, I'll have to go through the documentation to understand what all the values can be returned by services, or I have to go through the JSON or XML payload to understand the data that is being retrieved from the services. Like in this case, service has projects, addresses, and audits nested into it. So in that case, you can go with employees, the ID, and projects, addresses, audits. So this makes it more readable, and you can right away understand, okay, I want to get the projects, just pass the resource name as projects. So here you don't have to tunnel through like services, then it comes project, addresses, and audits. It minimizes the nesting also, and it makes it very clear to understand. So that's the reason you should avoid using abstract or concrete nouns. Next up is the conventions to name the resources. For example, if it is a single word resource, then go with lowercase. If you have multiple words, then separate those words with hyphen, which is also known as kebab case. And if you want to get the field name, then just make the resource as camel cased. You should also consider resource granularity while designing the API. Resources should be coarse grained, and when accessing the data for a resource, the API should return all the information which is required to satisfy the request. And in case if you see the example, like employees, then the employee ID, and I have a resource addresses, we have two different address, correspondence address and permanent address. So instead of this, what we can do is we can just pass address and return both the address. So retrieving all the data in a single call will be much more efficient than making two different calls. And then one can decide if he has to go with the correspondence address or permanent address. And considering the size of this data, it will be very small, so sending both the addresses doesn't is not a concern. So we can just go with addresses rather than going with correspondence address, permanent address, and making it more fine grained. So always ensure that the resource granularity is coarse grained. So far we have understood how to design resources. Now identifying associated actions for each resource is the next step in design process. Unlike any application, RESTful APIs also have CRUD operations on a resource. What's more, the CRUD operations seamlessly map to the HTTP verbs. For example, if you want to create a new product, you map it to the HTTP post verb. To read the product, use a get. To update, use put or patch. To delete, use delete verb. Now there are few things to take in consideration for post, patch and put methods specifically. We use post to create a new resource, like a products collection of resource. I want to create a new product. I'll pass the whole payload, whatever are the details that are required, and it will return me the ID or something that this product has been created. Now when using a put verb, it's used to replace the resource which is existing completely. So when you use a put, it's mandatory to pass the complete details of the product in the body, like product has name, ID and MRP. So you have to pass all the three fields in the body, and the ID is optional. So when you pass the ID, it replaces the product present at that ID. Like if at 1 2 3 4 there was some product like soap and it had its own detail, it would replace that soap product with ID 1 2 3 4 with the streamer product which is having ID 5541. So a new version of that object gets created when you use put. When you use put without the ID, it will behave as a post request. It will create a new resource with the ID present in the body. So remember, put can also behave as post, but post cannot behave as put. Next is patch. Patch is used when you want to partially modify a resource. If you want to completely replace the resource, use put, but if you want to partially modify the resource, use patch. For example, I have product 1 2 3 4 and I just want to change its MRP or maybe the name. So I'll just pass only two fields, name and MRP. You only need to pass the fields that you want to change. Other fields should not be added. Like I don't want to change the ID, so you do not pass the ID. So that's the difference between put and patch. Put will completely replace the existing version and you have a new version of that object, whereas patch does not replace, it just modifies the data. And using patch, you just have to pass only those details that you want to modify, whereas in put you have to pass the whole details. Whatever details are present for that object, you have to pass them. Other important factor while choosing put, patch and post is that put and patch are idempotent. What it means is that if you fire multiple put or patch request, it won't have any effect on the resource. The resource remains unchanged. It's only the first time when you hit it, it will change the data, and after that a multiple calls to that resource using put or patch will effectively have no change. Because if I change the MRP of product 1234 to 6000 and I hit a request, so it will change the MRP to 6000. But if next time I hit the request, there's no point, right? MRP is already 6000 and I am hitting the same request again and again with MRP 6000. It doesn't have any effect. And same is the case with patch. It has got no effect if you hit the same request again and again. But in case of post is non-idempotent, so if you hit it again and again, it will just throw an error because it won't be able to create the same product with the ID. It will throw error. So these are a few points to take into consideration while creating your APIs and using the verbs put, patch or post. Ensure that the API returns proper status codes and payload as required. Status code are the most commonly used status code are 2x series, 4x series and 5x series. So at least this set of status code should be present in any API. So let's take a look at the 2x series, which determines success. So if the response is 200, it is okay that the transaction was successful, and it can be returned for get, post and put verbs. Now you might be wondering, how can 200 be written for a post when it should be 201? Well, you are right, but there could be chances when your post behaves as a get request. For example, you want to get details of an employee, but you are supposed to pass in a lot of details to get the details of that employee. So in that case, it's not possible to pass all the required details in the form of query parameters. So instead you use the JSON body to send the request, and in that case, if you pass the details, you get the response. So this is a scenario where the post can behave as get and you can expect a 200 response. Same is the case for put. Now 201, if a new instance of the resource gets created using post, you return a 201, and same for put. When you create new instance using put, like complete new instance. And 204 is when the content does not exist and you try to delete, like the resource is already gone but you are again trying to delete it. So that's when you get 204. Then next is the 4x series, which tells the error is at the client side. So it's 400 bad request. If there are some missing fields in the request, you have to throw 400. 401 when something is wrong with the credential, like they are missing or you have passed incorrect credentials, that is when you return 401. 403 when your request is valid, your credentials are valid, but you are not allowed to access that resource, that is when you give a 403 response. And 404 is not found when the resource itself does not exist. Then 5x error, which are server error, means the errors with your own application, the API implementation. So 500 says that the request was valid, the API accepts the request, but due to some unwanted condition, the API is not able to fulfill that request. So that's when you return a 500 error. So any error occurring in your API implementation, it has to be wrapped into a 500 internal server. Now if the API is unable to respond to any requests coming, you should return a 503, like service unavailable. For example, the API implementation is down for some maintenance work. In that case, it won't be available to access. So sending a 503 makes sense. So usually this is being sent from the gateway when it's not able to access the API implementation. There is an exhaustive list of status code, but at least you should ensure that while designing, this status codes should be present in the API. There could be many more depending on the requirements, but this is the minimum requirement of status code when designing the API. The API consumer may only need a subset of a collection of resources. This can be done by filtering the data using query parameters. So in this example, I want to get the details of active subscriber, so I can use a query param called status and give it to active. So this will return me the complete details of the subscriber whose status is active, meaning if there is a subscriber table and it has fields like name, ID, gender, age, country, it has to retrieve all the values of those fields associated with the subscribers whose status is active. So it returns all the fields of active subscribers. And if you want to filter on multiple criteria like status is active and country as India, so you can use and give the next query parameters. Now if you want to sort, so this can be done by just adding a query parameter called as sort and give the field on which you want to sort the data. Like I want to sort a name, so I gave name, and by default it can be assumed as ascending order. If you want to sort based on multiple fields like name and age, so you can separate those two values using a comma and send them. So this will sort the subscribers based on their name and age, and by default it will take an ascending order. Now if you want to specify the order in which they need to be sorted, for example, I want the name to be in ascending order and the age to be in descending order, you can use the plus symbol to denote ascending order and the minus symbol to denote descending order. If you find plus and minus symbol a bit confusing, you can also try out ASC and DSC. So use underscore and append it with an ASC and for ascending order, and for descending order append with underscore DSC. So that is how you can do sorting when querying the API. Next is searching. So everyone wants to search, so you can use a search query parameter, and in this case, like I have given Rodriguez, so it will search for all the subscribers who have Rodriguez in their name. It's not saying that its name is Rodriguez, but it should have Rodriguez in its name. So any subscribers, means if there could be 1, 2, 3, it will return all the subscribers that will have the name as that have Rodriguez in their name, and it will also return the complete data, all the columns that are present in the subscriber tables, everything will be returned. Now another important thing is pagination in the API. Suppose there are hundreds and thousands of records, so fetching all those records in a single call is not possible. It could be possible for 1,000 records, but what in case if there are millions of records? It can either go to a timeout or you can run like out of memory or something. So it's very important to consume the messages in installments. So that's where pagination comes into picture. So suppose I want the subscribers and there are millions of subscribers, so I can use the limit keyword and the offset keyword. So these two query params can be used. Now this originate from SQL. So what limit suggests is how much the page, how many records the page should contain. So specifying a limit tells you that it will only return you the 10 records. Now when you specify the offset query params, so in the first case it returned you 10 records. In the next call, if you make this second call, this was the first call, limit equal to 10 without any offset. In the second call, you have specified the offset of 10, so it will return you the next 10 records. Total is 20 as of now because there were previous 10, and now the next 10 records have been returned. Again, in the third call, when you specify the offset as 20, it will show you the next 10 records. So that is how in installment of 10 records you have received a total of 30 records in 3 steps, as opposed to a one single call returning you all the 30 records. So that's when you use a pagination, when there are millions of records and you cannot show or display or retrieve in one go, then you use pagination. Partial resource. So far, whatever queries that we have seen, like searching, pagination and filtering, sorting, in those we were retrieving all the fields like ID, name, age, country, gender. But what if you do not want all the fields, you just want specific fields? That is when you should use partial resource. For example, I want the subscriber 1234 and I just want the fields name and age. So you use the query parameter fields and just specify what all fields you are interested in, like name and age. So this is how you can use partial resource to get only specific field, whereas all other queries like searching, pagination, sorting and filtering were returning all the fields. So for getting specific fields, use a partial resource, specify it using the fields query parameter. Now you might be confused when to use query parameters and when to use URI parameter. So when you want to get a subset of data from the complete set of data, if you just want to get a specific subset of data, you go with the query parameters. But when you want the complete data for a resource, like in this case I want the complete data for resource 1234, subscriber 1234, I'll go with the URI parameters. So that's the difference. If you want a subset of data, like it can be a collection but a smaller collection based on some condition, you use query parameters. But if you want to get a resource which is dynamic, you use a URI parameters. Now suppose you have a complex query that has been implemented, like I want to get the name and age of the subscribers who have subscribed from 14th June 2019 to 14th June 2020. So this implementation is fine, like it has the fields and we have given the name of the fields and also from and to query parameters, but it's not readable and it becomes difficult to understand. So what we can do is we can separate this from and to query parameters and club this into a logical resource name, like in the second URL. The from and to are effectively telling a period of 1 year, right? From 14 June 2019 to 14 June 2020 is a span of 1 year. So what we did, we replaced this from and to with a last year resource, and then we can use the fields query parameter to get the name and age field. So this is last year resource name is an alias. So we are using an alias for the query parameters, which makes the query more readable and consumer friendly. Now that we have understood how to design resources, verbs, query parameters, and URI parameters, it's time to understand the proper URI structure that should be followed. So to demonstrate, I have two APIs, external and internal, like we discussed at the beginning of this video, that there could be external facing APIs and internal facing APIs. So the convention is slightly different for both the APIs. So let's take a look at the external API. So the protocol, then there is a domain. So the domain is the domain of the enterprise. Like in my case, I have given as my-api.com. So this could be anything. It could be replaced by the domain of your enterprise. Then by default it's API, then API-name. So this typically represents a business or utility service and should be short but a descriptive name. For example, in this case I have said it to be a studio. Next is the version. So version would include only the major version. It should not include the minor and the patch versions. The reason behind this is the major versions are not backward compatible. So that's the reason you only include the major versions. Then the resources. So this represents the name of the resource that represents the actual object. An API may contain one or more resources. The resources can also be referred to as API endpoint. Then there is the resource ID. So this is the ID of the resource to be fetched or updated, and this is optional and is not applicable when you do a post request, because in post we do not know what is a resource ID. We are actually creating the resource, so as a response we get the resource ID. Now query parameters, as you know, those are strings that are often used to carry identifying information in the form of key value pairs. For example, in this case I want to get the fields like name and age. So this is the final API URI that has been realized following this taxonomy. Like the protocol, the domain name is myapi.com, API default, then API name is studio, which is the name of the application, then the major version v1, then subscribers is the object that my resource is representing, then the actual resource ID like 1 2 3 4, and then the fields that I want to retrieve is denoted by a query parameter. Now if the API is an internal API, there's a slight change that we add a layer to it. Rest all the things are same. So when I say layers, it is one of the layer from the API led connectivity. It could be a system layer, process layer, and experience layer. So if it is system layer, you just need to add sys. If it is a process layer, add proc. If it is experience layer, add exp. So the only thing you need to add is layer in case if it is an internal API and if it is following the API led connectivity. If it does not follow API led connectivity, you need not add the layer resource. Now there is one point to take care of, that The resource name should remain short in order to avoid any size limitation. For example, the resource name over here is subscribers. It could be a lengthy name as well depending upon the use case that you have, so try to keep it as small as possible because there could be size limitations. The other thing to notice is the base URL should not contain more than 2 to 3 resources if possible. So like API Studio, so it's fine 2, API Sys Studio, it's fine 3, but try to limit the base URL up to 2 resources or 3 resources. Do not increase more than that because it indirectly affects the readability of URL and it unnecessarily lengthens the URI. So these were the few best practices that should be followed while designing the APIs, and I believe if you follow this recommendations, the API will be well designed, consistent and intuitive, thereby helping you to get better performance from the API and improve the overall productivity of the team. I hope you found the video useful. Thanks for watching.